Okay, so the first vocabulary term is the zero of a function, and this is where the graph crosses the x-axis. Where the graph crosses the x-axis. And we know a quadratic makes what shape, what type of graph? Abby? A parabola. So if you're thinking about visually our x and our y-axis, we have a parabola. Could be upward facing or downward facing. The zeros would be right here. And I kind of introduced this term yesterday when we were talking about this. So that's what we actually found yesterday with the zeros when we solved it by factoring or by square rooting. Typically you're going to get two of them. You can get one if the graph just comes down and touches and turns back around. You actually also can get none. We're going to look at that later on with imaginary numbers, and that's when the graph would actually kind of be up on the y-axis. All right, so not every quadratic can be solved by factoring, like we did yesterday, or by finding the square root. When this happens, one of the methods we'll learn today is the graphing calculator method. And I have the steps typed out for us. Let me open my graphing. Our function, so x squared minus 5x plus 2. This one was in standard form, so nice and easy. You can see this is not factorable also, right? We don't know any numbers that multiply to 2 and add to -5. So it would be not factorable. So you'd have to do it with the graphing calculator. All right, we're going to press zoom and either arrow down to 6 or just press the number 6. It's much faster. And that'll get us a pretty good picture of the graph. So it kind of looks a little bit like this one. So we'll do the left one first. So press second trace. This is where we used to find the vertex, min and max, but we're looking for the 0, option 2. So here comes the questions. We want to be to the left bound of, and you might want to take your cursor and put it on the 0, like that's approximately where the 0 is. I want to be to the left of that point. So hit the left cursor a couple times. It doesn't matter how many times, just somewhere to the left, hit enter. You'll see a little arrow pop up, and that's showing like where it's pointing. Okay, right bound question mark, hit the right arrow until you're to the right of it. You don't want to go all the way past the vertex. You just want to kind of like sandwich the 0 in between those 2 points. Hit enter. And if you do this correctly, the arrows should point and face one another. Does everyone see that? These 2 arrows up here? All right, guess, get as close as you can, and hit enter. And there's our 0. They tell us to round to the nearest hundredth, which would be 2 decimal places, so that would be 0.44, 0.44. Now, technically, you can do this for factorable ones, too, like yesterday. That's why part of your quiz Friday will be no calculator, because you could technically do this for all of them. And we have to make sure you know how to do it both ways. Now, we have to repeat that whole process for the other 0, this one. So second trace again, and 0, option 2. And then toggle all the way over till you get to the approximate 0. You want to be to the left of that, which this time left is underneath the 0, this direction. Hit enter. Go to the right, just somewhere over to the right again. Look for your arrows facing one another. If they happen to be facing different directions, you did it wrong. And then guess. 4.56. Is anyone not getting this? Is anyone getting an error? All right, the next one, we would have to get in standard form, so we would need to subtract 4 both sides first. And I want you guys to try this one on your own. We're actually going to skip probably C and D, but we'll see. You guys need anyone that's not watching? Never know. Oh, Sam might be watching. Down in North Carolina. No, probably not. Hi, Sam. We miss you. All right. On the back, we have 2 word problems. One's actually a geometry problem, which many of you will enjoy since you're doubling up this year. Both classes. Okay. The nice thing about these word problems is that they do typically give you the equation. We just have to interpret it. So it says smoke jumpers are in free fall from the time they jump out of an airplane until they open their parachutes. The function y equals negative 16t squared plus 1600 models a jumper's height y in feet at t seconds for a jump from 1600 feet. How long is a jumper in free fall if the parachute opens at 1000 feet? So how long would be the time, which means we're looking for what is t. Okay, what is the value of t when the height is 1000 feet? So that would get plugged in for, they tell me, y is height in feet. So they're telling me that y is 1000. So you're going to take 1000 and plug it in for y in our equation. All right, now there's two ways that you can solve this. We're going to use the graphing calculator, but you could also, would we want to use factoring or square rooting based on the format we see here? Square rooting, we're missing the bx term, okay? So you could choose square rooting, which a lot of you will actually find easier than the graphing calculator for a problem like this, because the numbers are going to get large, so us trying to find the graph is a little bit harder. But I want us to try it, and we'll do the graphing calculator. Either way, whichever way we do it, well, I guess if we were doing square rooting, we'd move the 1600 over. But to do graphing calculator, we need to get it in standard form. So get it set equal to 0. If you were square rooting, you would subtract 600, divide by negative 16, and then square root both sides. The two negatives would divide out to be a positive, so you will get a positive answer. But I want to practice this on the graphing calculator just to show you guys how to modify your window. So we'll go to our y equals. Now you will have to use x in the calculator instead of t. So go ahead and input that function. You want to input the one that we modified to have set equal to 0. So negative 16x squared plus 600. And if you press zoom 6 first, it will look like there's just like 2 bars, 2 lines. Okay? And that's because the parabola it's much larger than the picture is. So the second option you want to try, and I'm going to tell you this doesn't always work, okay? But zoom 0 is a good option. So zoom 0, you could just press 0, but that will fit the graph. It'll try to find it and like fit it to the screen. And you can see that it kind of is better. Okay? It's good enough. We can't really get the vertex, but you can definitely see where the zeros are. Okay? So I'm going to go ahead and say let's not find this one. Why? It's a word problem. Think about what t represents. Time in seconds. Right, we're not going back in time. So we can't have negative time. So you don't have to waste your time to do that one. So we're only going to have to find the positive 0. So we'll press second trace. Option 2 for 0. Now sometimes when the graph gets really big like this, like the cursor, you can't really see it. You just have to keep hitting the arrow button until you find it. You can use the x and the y coordinates to kind of find out where it's located if it ever goes off the screen. Okay, but here's the vertex, or not the vertex, the 0. I want to be to the left of that, which would be up here this time, because left is this direction. So left somewhere here, hit enter, right, keep hitting the right key until you get past the 0. Again, your arrows should face one another, and then we'll do our guess, and we should get 6.12 seconds. Make sure you have a label on there. So again, zoom 6 and zoom 0 are the two that you're going to typically use when finding the graph here. Okay, your left bound is fine. Your right bound needs to be to the right of the 0. Like yours is on the 0. So you kind of want to check. So left will be somewhere like here. Right will actually be like below it, like to the right of it. And you want to make sure it's like sandwiching, so there's a little bit of space. And then your guess would be right there. Okay. All right, the next one is geometry, just because it's shapes class. Carpenter wants to cut a piece of plywood in the shape of a right triangle, as many carpenters do at some point or another. He wants the hypotenuse of the triangle to be 6 feet long and the legs to be shown as the diagram. So one of the legs will be 1 unit longer than the other. About how long should the perpendicular sides be? So how long should the 2 legs be? Well, there's no equation, so we're going to have to write one. What kind of equations or formulas do we know that might work with a right triangle specifically? Yeah, the Pythagorean theorem. And that relates to the sides of a right triangle. So A and B are the legs. It does not matter which one you label A and which one you label B. The hypotenuse has to be C. That's your longest side. Now, since this is a monomial and this is a binomial, you will want to group the binomial, x plus 1 in parentheses. And then we'll substitute in. So we'll get x squared plus x plus 1 squared equals 6 squared. And I'm solving out for x, and I'll plug it back in. So can I just go ahead and like square each of these and make it x squared plus 1? Am I allowed to do that? Can you square a binomial? No, I'm seeing some head nods now. I would have to expand this first using FOIL. Okay, so expand it to be x plus 1 times the quantity x plus 1, and then we'll FOIL that. So this x squared will stay here. This one's going to get me x squared plus 1x plus 1x plus 1 equals 36. Now we can combine our like terms on the left to get x squared plus x squared is 2x squared plus 2x plus 1 equals 36. And then in order to use the graphing calculator, we do need to get it set equal to 0, so we would subtract 36 on both sides to get 2x squared plus 2x minus 35 equals 0. Now, if this were not on this section of notes, you could try to factor it if you wanted to. I'll tell you right now, just looking at my answers, it's probably not factorable. But since this is a graphing calculator question, we're going to go ahead and type this in our graphing calculator. Again, always start back at zoom 6, so do not just press the graph button every time. You always want to reset your calculator to zoom 6, which is your 10 by 10 window, every single time. So zoom 6. Okay, now I can't see the bottom of it, but that's okay. The only part that you need are the 2 zeros. Now, sometimes you do have to find the negative one for a problem like this. Let's suppose this was like a negative 2 times x. Then that would get you a positive number when you plug it back in. But since one of the values is x, I know that this one can't be it because it can't be a negative number. So I'm only going to find the positive one. So we'll press second, trace, option 2. Now my cursor is like off the screen. This is what I was talking about. Can't see it. So just keep hitting the right arrow over and you can see the numbers. So we're coming up. There it is. All right, so the guess is not going to be super great. It'll be somewhere close, but it's not going to be on it because it's going to jump pretty significantly. So to the left is this direction, which the curve happens to be underneath. So left bound will be underneath the curve. Right bound, somewhere above the curve. Again, your arrow should be facing in. And then we'll do our guess, which the guess is really not a very good guess because it's jumping over the 0, but just get as close as you can. We should get 3.71. And that would be feet. The other side is 1 unit longer, so we add 1 to that to get that the other side is 4.71 feet. And those are the lengths of the other 2 perpendicular sides. Okay, I'm gonna let us skip the closure just because I know you have a lot of homework problems that you're gonna do these same types of problems on. So I'll pass that out to you guys and you can get started. If